And we're back and better than ever, still in 18-4, where we're dealing with the spontaneity of reactions. In the last podcast, we introduced you to the idea of spontaneity or non-spontaneity, and we talked about two of the factors that influence whether or not a reaction is spontaneous or not: enthalpy and entropy. In this particular podcast, we're going to talk about free energy and how all of those are related to one another. So let's go ahead and jump in. Free energy, or is also called Gibbs free energy after Willard Gibbs. He was an American chemist in the 1800s who helped develop this idea, is given the symbol delta G in honor of Willard Gibbs. And free energy is defined as the maximum useful energy available to do work. Now, we're not going to unpack exactly what that definition means, but the basic idea is this: there is energy involved with certain reactions. Not all of it is really available for work. So that maximum amount that you could harness from a particular reaction is referred to as the free energy. And so let's take a look at a couple of scenarios. If a system has a delta G that is less than 0, meaning it is negative, that process is losing or releasing free energy. That means that the reaction is going to happen. The reaction is spontaneous. If a reaction can use its energy and apply that energy to another system, it's going to do it. On the other hand, if delta G is greater than 0, meaning positive, it would have to absorb free energy, meaning it's going to have to take on energy. Well, that just doesn't naturally happen on its own. The reaction is non-spontaneous. And in fact, the reverse reaction would actually happen. There's one other scenario that we hadn't really looked at with entropy and enthalpy, is the fact that these things could in fact equal 0. Well, in the case of delta G, if delta G is equaling 0, it means that there's no change in free energy in either direction. And if there's no change in free energy, no free energy change, that means that the system is not undergoing any change, and that would mean that that system is at equilibrium. Because you have no overall change happening. And that system cannot change once it is at equilibrium unless you take it out of equilibrium, which means that you're going to have to be influencing it from the outside. But once something is at equilibrium, it is not going to change in free energy. Delta G would be equal to 0. Now, how are all three of these related to one another? As it turns out, delta G is going to equal delta H minus the absolute temperature T delta S. Delta G equals delta H minus T delta S. You're going to have that written on the back of your periodic table, and we'll be able to use it on tests and quizzes. But let's talk about what this in fact means in terms of spontaneity. Well, first of all, if delta H is negative, that is favorable. If delta S is positive, that is also favorable. It means that it's becoming more random. With this negative sign out front, notice there is a negative sign right there. If that negative sign is out front, it's going to take this positive and make that whole term negative. So now you have a negative and a negative, which means that delta G must be negative. If both delta H and delta S, if both the enthalpy and entropy are favorable, the reaction always happens. It is always spontaneous. On the other hand, what if they're both non-favorable, meaning you have an endothermic process, delta H is positive. It becomes more ordered or less random, so delta S is negative. The negative out front times this negative will make this whole term positive. And so now delta G is going to be positive, which we've already said is never spontaneous. Now, the question is, what if one suggests a reaction is spontaneous while the other does not? Well, let's just say, for example, that this is negative, and this which is favorable, but this make this also negative, which is not favorable. This whole term becomes positive, doesn't it? So now you have a negative and a positive. So if you have a negative plus a positive, will delta G be negative or will it be positive? Well, actually it depends. It depends on how big this negative is and how big this positive is, which basically comes down to how big the temperature is. And so therefore this thing becomes temperature dependent. Temperature dependent. At some temperatures it is spontaneous, at other temperatures it is not spontaneous. Now that might seem a little odd at first glance, but in fact we experience this every single day. So let's go ahead and take a look at two normal everyday occurrences that are temperature dependent. So let's fill in our delta G equals delta H minus T delta S. And let's take a look at the freezing of water. When water freezes, the water has to lose energy or lose heat. So it's actually an exothermic process. That's somewhat odd because we think of ice and water being cold as the freezing process occurs, but it has to lose energy. So it is delta H will be negative. As you go from water, liquid, to ice, solid, the system becomes less random, meaning it's got a negative delta S, and this entire term will be positive. So, the question is, at what temperatures, notice you have one negative and one positive, and so it's obviously temperature dependent. The question is, at what temperatures does delta G become negative? Well, the only way for delta G to be negative is for this to be greater than this, which means that this positive will have to be small, meaning that the temperature will have to be small, which means you're going to have a low temperature. So this will be spontaneous at low temperatures. And we know that water will freeze at low temperatures. It is a spontaneous process at low temperatures. We've also said that the opposite is true, so that as you have high temperatures, when the temperatures become greater, this is a non-spontaneous process, but then the opposite becomes spontaneous. So at high temperatures, the melting of water will become spontaneous, and you've also experienced that as well. In terms of boiling water, in order to boil water, delta H must be positive. You must add energy into the water to boil it. However, as you go from a liquid to a gas, it's becoming more random, which is favorable, so that delta S will be positive. The negative sign out front changes this sign, so that will make that whole term negative. So once again, when will this thing be spontaneous? It will be spontaneous when this negative sign is large enough, meaning you have to have high temperatures. So this is spontaneous at high temperatures. All right. In the next podcast, we'll go back and review this. Also, give example number 1 on the next page of the notes a try, and we'll go over that as well in the next podcast. We'll see you next time.